Hello again. This is a bonus lecture as well, micro lecture, but you still need 3 or more bullet points worth of notes, 1 to 2 sentence summary, and do your follow-up questions on Google Forms. Okay, last time we talked about this idea of the independence of motion, the idea that if something is falling and something is moving sideways and then also falling, that they still fall at the same rate. So we've got a white marble here that falls in just the same amount of time as a red marble being dropped, simply because gravity isn't affected by sideways movement, assuming it doesn't have wings or some sort of like flight capabilities. So what this means for problem solving is we can solve for vertical speed, distance, or acceleration by pretending it's not moving sideways. So if we want to know how long it takes to fall, we just deal with the information related to falling and ignore the fact that it's moving sideways. When we're ready to figure out how far sideways it's moving while falling, we can ignore the fact that it's falling and just use information related to its sideways movement to figure out how far sideways it's going to move. So in practice, what this means is we can predict where something will land before it lands. And the way we're going to do that is by, again, kind of pretending it's just moving sideways. So if we've got a marble that's going to roll off the table, and be like, oh, well, it starts here, and then after 1 second it's here, 2 seconds it'd move this far, 3 seconds there, 4 seconds there, almost like gravity didn't exist and it's just rolling along a table. Then we can figure out, well, let's just pretend we were dropping it. Well, after 1 second it'd be here, 2 here, 3 here, and 4 here. And those arrows would represent its velocity in those situations. In the end, what we can do is just add those together. So in this case, if it's gone this far sideways and this far down in 1 second, you add them together and you get that its new kind of location is right there. And we can do the same for after 2 seconds, 3, and 4 in this case. So let's give this a shot. Let's do some practice on this. A car drives off a cliff, a 45-meter tall cliff at 20 meters per second. Go ahead and calculate how far sideways it would go based on this. So we're going to walk through this together. If you think you can do it on your own, then pause now and then go ahead and move through and solve afterwards. Okay, so a car is driving off a 45-meter tall cliff at 20 meters per second. We want to calculate how far sideways it goes before landing. Well, step 1, we need to calculate how much time it takes to reach the bottom of the cliff. Mainly, pretend that it's just falling straight down and figure out how long that's going to take, because then we can know how long it's in the air. So your hint is to treat it like free fall and just ignore the sideways speed. So if you want, pause the video, see if you can give it a shot on your own. Alright, so in this case, the given information that's relevant, gravity is 10. The distance it's falling vertically is 45 meters. Our unknown is time, so we plug into d equals 1/2 gt squared, and what we get is that the time it takes to fall is 3 seconds. So we know this thing's going to be in the air for 3 seconds. So that brings us to step number 2. Calculate how far sideways it goes in that 3 seconds of air time. So you're going to ignore that it's falling, but you're still going to use that time from step 1 because that tells you how long it gets to move sideways for. Go ahead and solve that if you can. Okay, so in this case, we know that its horizontal velocity is 20 meters per second. That doesn't change because although it's falling, that falling doesn't change its horizontal speed. They're independent. So it's going to continue to move sideways because there's no net force in the sideways direction. We know it's going to continue to fall, it's going to fall for 3 seconds, so we plug into v equals d over t, and what we get is that it will move 60 meters sideways. So if we are going back, then what that means is, while it's falling, it will have traveled 60 meters sideways in the time it takes for it to fall, and so that's what we're going to figure out as our answer for down here. That's it for this one. 3 or more bullet points worth of notes, a 1 to 2 sentence summary, and your follow-up questions on Google Forms. And our image credits are the following.